When we go to use chemicals in a reaction, or in a recipe if you will, we need to know what the mass of that compound is for a particular unit, for a single unit of that compound. And this is known as the formula mass. Now, sometimes we use the terms molecular mass or molecular weight, and sometimes even molar mass, which we will get into in another lesson. All of these names, the values that they represent numerically, they're all calculated the same way. The difference is in the context of what you are referring to the mass of, whether it's a single unit, a single atom, a single formula unit, or a single molecule of the substance, or in the case of molar mass, if you're talking about a mole's worth of that substance. Now, the term formula mass is the most generic of all terms. It simply means for all the elements present in the formula for the compound, you add up their atomic masses from the periodic table. Now, the term molecular mass is a more specific term which really only applies to molecular substances, and those are things that bond covalently. So typically if we're talking about non-metallic elements bonded together. And really that's the only time we should be using the term molecule and molecular mass. So for instance, if we're talking about water, which is a molecular substance, we can talk about the molecular mass or the molecular weight of water. However, something like sodium chloride table salt, that is an ionic compound, so we shouldn't use the term molecular mass for sodium chloride. We should use formula mass. But mathematically speaking, you do the exact same thing. You simply sum the atomic masses of all the atoms that are in that particular compound. Now, as a general rule, you look at different periodic tables, they will report the atomic masses to different numbers of decimal places, different precisions. But as a general rule, we typically take 3 significant figures from the mass that's given on the periodic table, and we round off to 3 sig figs. So those would be the numbers that we use in our calculations, and consequently then, for many of our calculations, the final answers would then be rounded to 3 sig figs as well, although you need to double check all the values that you're using. If we take calcium nitrate as an example, looking at the formula, we see that we have 1 calcium atom. Distributing the subscript through the parentheses gives us 2 nitrogen atoms and 6 oxygen atoms. Going to the periodic table and finding the atomic masses for each of these elements to 3 sig figs, we take it times the number of atoms that we have for each one respectively. So 1 times 40.1 for calcium. For nitrogen, 2 times 14.0. And for oxygen, 6 times 16.0. And then we sum total these amounts. And in this case, because we're adding, we go with the least accurate decimal place for our rounding. They all go to tenths, so we aren't going to need to cut any answers or any decimal places off. And we come up with a final answer, a final formula mass of 164.1 atomic mass units.